Yo, I helped you understand WebSockets. Awesome. What's up, Daniel? WebSockets are so fun. There was once upon a time we actually covered WebSockets in 116, only one semester, and then I realized it was a big mistake. Or actually, I think 2 semesters. It was a big mistake though. But in 312, WebSockets all day. Nice. Doing independent research with Hunt. Alan's awesome. What's a WebSocket? Oh my, I don't. I wish you asked a minute ago. I could have gave you a quick answer. It allows two-way communication between someone visiting a website and the web server. That's my super brief answer for that one. All right. So I hope the quiz went well. Anybody with really quick questions about the quiz? It might take a little bit of time, but I only have an hour and 15 minutes to talk about reading files, parsing CSV, and everything to get you ready for programming task 6, which I should at least mention. So today is the programming task 6 lecture. Unlike the last testing lecture that followed a quiz, where it was just like tips and tricks on the homework, this one there is content that you are responsible for. This is showing you how to do programming task 6, which is reading 2 types of files. We have 2 different types of data here. One file that's going to have data about songs, one file that's going to have data about movies, and that song and movie class that you created in task 4, I guess song you created in task 2, but the classes that you have, we're going to start creating data structures with objects of those types by reading CSV files and populating those data structures from the data in the files. Quizzes were good? Nice. That's good to hear. I always like to hear that, hear when you crush the quizzes. I say, I hope it's okay. I submitted 2 submissions for data structures too because I had 2 papers. Can you send an email to myself and Gerline to remind us about that? Because by default, we'll just grade your latest submission. So send us an email to remind us that we need to look at both submissions to get both of your papers. We want to know how to parse these CSV files, and we also want to know how to test them. You do have testing requirements to test these methods that are going to read the songs file and read the movies file that that you're writing methods for. Can we talk about in-out for a second quiz? I don't remember. Actually, I can just run the code and tell you what the in-out should be if you're just wondering what the actual answer should be. I forget off the top of my head. It was a pre-order traversal, but I forget, let's see, quizzes, int tree, let me run no, I put the code in binary tree node, run it. And it's 10, 7, 8, 12 is the correct order of the output. So hopefully you got that order, because we are looking at the order. Did you follow the traversal right? The order is pretty critical to that quiz. So getting the order right on that output is of critical importance. Gerline and I talked about the, because every getter actually has a stack frame, and keeping track of like what this is in each stack frame and what all the references in every single stack frame. If you made some small mistakes in there, we're okay with that. But you have to show us that you know that this is a pre-order traversal. This is the order that it's going to be navigated in, because we want you to understand the trees. That's the concept that's being assessed. So we want to make sure you understand how the trees are working. If you missed a couple getter calls, because the quiz had so many getter calls, get this, get that, get this, I tried to remove them, but there wasn't like a clean way to get rid of them and still set up the quiz the way that I wanted it to, because I wanted it to mirror the homework a little bit. So if you're struggling with the tree homework, task 5, if you're struggling with that, the quiz is meant to show you like, here's an example of how it works on the homework. So a bunch of getter calls on the stack. That was kind of just an acceptable loss, which I don't think is too bad, given that we got some other good properties in the quiz. All right, so reading files. Let's talk about what you need for task 6. I would like to talk about the quiz longer, but I don't have too much time to get through all this, so let's do it. So why files at all? We're going to talk about reading files. Why even do that? We've been getting along just fine with data structures so far. We have all our data in data structures. That's why they're even called data structures. That's where our data goes. So why even store data in files? Well, the problem with data structures, not necessarily the problem, it's by design, but the problem with data structures is that they're stored in memory. So when your program ends, from all our memory diagrams, we know that when our program ends, all memory gets freed up, all the stack, all of the heap, it all gets freed up and sent back to the operating system. So every single data structure in your program is destroyed when your program ends. So you can't have that data persist. That data doesn't live any longer than your program. And when a program starts, you have no data structures and no data. You have to create it all in your program to get them in memory. If you forgot to mark X, like if you forgot to cross out a stack frame, that's perfectly fine. If you make a lot of little mistakes like that, that can like tip you over the edge if it's a borderline, if we're not sure how to make a decision, if it's a pass fail, and you also didn't cross out your stack frames, that can, in some cases, tip you over to a fail. But if that's your only mistake, we're never going to fail somebody if their only mistake was not crossing out stack frames. Except maybe on the first quiz, but even then, it's about references and objects and stuff. Not really, did you remember to cross out your stack frames? Lots of little mistakes can add up, though. So we want our data to live longer than our programs, and we want our data to exist as our program starts up, and that's why we're going to use files. Files are persistent storage. They're stored on the hard drive, which we call disk space, as opposed to memory. This is outside of the stack. This is outside of the heap. This is not on your RAM sticks at all. This is in your hard drive. It's a completely separate part of your device, and that does persist. All programs that are running share the same hard drive, and they can all access that hard drive to access that persistent storage, either store files on the hard drive or read files from the hard drive. So this is why we want to use files. It's for persistent storage. So let's read files. Hopefully that's enough motivation. You're all pumped about reading files, which you already read files in 115. So the concept, that's more of just a reminder. But new Piazza question. You should be watching lecture. But let's read files in Java. We already did it in Python, so let's do it in Java. So here's my simplified example. This is about as simple as I can make file IO in Java. So let's go through this piece by piece and see what we're looking at here. But this code, this method here, will take the name of a file as a string and return an array list of strings where the array list contains all of the lines of that file. So if this is a string that is the name for a file with 5 lines of text in it, this is going to return an array list of size 5 where each element is a single line in the file. So that's what this does. Let's see how it does it. So first, and this is for those of you who know already, this is an incomplete example. We're going to add to this to make it actually work. But I want to keep it simple at first instead of my usual approach where I dump a ton of code at you and explain it. There's a few new concepts here, so I want to break it down a little more granularly. So before reading a file, we need to get a path, a Java object called a path. And for that, we're going to use the paths class to create a path object. But this class uses a little bit different syntax. We're not going to call the path constructor directly. We're going to use this static method named get that's part of the paths class, call that method with our string, and it's going to look for a file with that name and return a path object with the information, the pathing information for that file, of how to locate that file on your hard drive. Paths actually can take URLs. It is pretty powerful, but here we're going to use it for file names only. So this is going to give us a path, and we're importing the class to have access to the static get method. So just some overhead that we have to use because we're using Java, and that's the way Java wants us to do this. Similarly, the files class has a static method named readAllLines. So we're going to import the files object, files class, to be able to get access to this static method readAllLines, which takes a path as a parameter. We can't just give readAllLines a string that's the file name directly. It takes a path, which is why we have to do the paths thing here. So we get a path representing our file that we can feed into the readAllLines method. Then readAllLines takes that path and returns a list of strings, which is going to contain all of the lines of that file. So this actually goes to the hard drive, reads the entire file, splits it on new line characters, and returns a list of all of those lines in one data structure of type list. I'll get to that more when we get to the next slide. But first, just to cover my basis here, this is a pretty inefficient way to read files. So anybody who's read files in Java before, you may or may not have done it this way. I think a lot of classes like to do it the buffered way, which is just a lot of extra complexity. It's a lot of extra lines of code, which is better and is the way you should read files once you get out there in industry and start writing professional code. This is just a very quick and simple way to read the lines of a file, which is fairly inefficient. It's perfectly fine for CSE116. It's also perfectly fine for small files. If you're just reading small files like under a few megabytes, this is perfectly fine. It's not going to hurt you too much unless you're reading those files like over and over again, you know, inside a loop or something, doing something like that. This is usually going to be just fine anyway. But this is going to fall apart when you start reading like hundreds of megabyte size files or even gigabyte size files where the contents of the file won't even fit in RAM when you don't even have enough memory. Say you're reading a 20 gigabyte file. Well, some of you have enough RAM for that. 100 gigabyte file. You can't just read all the lines and stuff it all in memory. It's not going to work that way. So what we do is buffer the input, where we don't read the entire file all in one go, but we read it one chunk at a time, usually by lines if it's a text file, or by number of bytes if it's a binary file, and read it partially each time, process the file, and then dump that content, that part of the file, out of memory, and then load the next chunk of the file into memory. So that's buffered. So this is an unbuffered way of reading files. We're just going to read everything and load the entire file into memory all in one go, take up a big chunk of heap space for the entire contents of the file. So for what it's worth, that's the difference between buffered and unbuffered. We're using an unbuffered approach, inefficient if we have very large files. It's going to be just fine to learn the concepts of reading files and talk about like objects and stuff that we want to talk about in 116. We're not quite ready, or not really ready, but we're not concerned yet about efficiency in 116. We're ready. I mean, I could easily teach it, but I'd have to remove something else from the course. It'd have to replace something else. So we just don't worry about efficiency yet. 250 is going to hit you with tons of efficiency. So is 220. So is probably, honestly, the rest of your courses. At least to an extent. So anyway, so readAllLines returns a list of strings. We haven't talked about what a list is. The very short answer is it's an interface that ArrayList and many other data structures implement, but we don't know what those words are yet. We actually will learn what they are next Tuesday when we talk about polymorphism. We'll learn all of that stuff, but we don't know any of that yet. And honestly, we know what ArrayList is. So let's just work with ArrayList. So the ArrayList constructor, the one that we've always been doing, the arrays.asList, and then giving a list of things, that constructor takes anything that implements the list interface, which readAllLines returns something that implements the list interface. So the short answer is, if you don't want to think about anything that I just said, just say new ArrayList and stuff that files.readAllLines inside the constructor. Now you have an array list that has the lines of the file, And then you don't have to think about working with a list or what that even means. Then we can save that conversation for next week. We can talk about that Tuesday. So now this method is going to read all the lines of the file with this name as a string and return an array list with all those lines. So we got all that part, but there's one big problem here, is that this code is dangerous. This is scary code to the point where Java won't even let us run this code. As is, this method won't run, it won't compile, it won't work at all. Java will refuse to run it because it's too dangerous. The problem is that this call right here can throw an exception. So what happens if we call this method with a string that we think represents a file, but that file doesn't exist? That's where the danger really comes in. And there's actually no possible way that we can call this method, that we can call paths.get and then read all lines. We can't call this in a way that we can guarantee that that file does exist. The best we can do is just handle the case for when it doesn't exist. If we call this method when the file doesn't exist, then handle that error as it comes. So it's going to throw what's called an exception, and we're going to handle that exception if the file doesn't exist. And we can't check that. So you might think, well, how about right before this line, we add one extra line of code that asks the file system, hey, does this file exist? And then if it returns yes, then we'll read the file. And if it doesn't exist, then we're going to not read the file. You might think that's a good approach, and sure, you should have those kinds of checks in your code. There's nothing wrong with that. But it's not 100% here, because every process on your device has access to the file system. So there is a very small window, an extremely small window, but a window nonetheless, where after your check is called, if this file exists, that the OS goes to the file system, checks, sees the files there, says, yep, it exists. And then immediately after, there's another process on your machine that goes in and deletes that file. And then you go call read all lines, and the file suddenly doesn't exist. Very small window, but if you have something, there might be a process that's like monitoring your file system, sees that you checked if the file exists, and then that other process reacts to that check, and then whatever that process does ends up corrupting that file. You could actually have some situation where that is reasonable, even though it's a very small window, very, very unlikely. There could be a situation where that process reacts to your check and corrupts the file, and then you're reading a corrupt file and everything breaks. So we can never get 100% guaranteed that the file will exist, because there is some amount of time in between our check and reading the file. What's up, Riyadh? So we have an exception. So what's an exception? An exception is something that is thrown by code when it gets a situation that it doesn't handle, that it doesn't address. And you've seen these already. We usually just call them errors. A method that doesn't handle a certain situation that it's put in, it's going to throw an exception. And if that exception isn't what we call caught, if we have an uncaught exception, the program crashes. So up until this point, whenever you get an exception, you don't catch exceptions. We haven't even talked about what that is yet. We will on the next slide. We haven't caught any exceptions yet this semester throughout your programming career, at least not in 115 and 116. So your program just crashes whenever you get an exception. And you've seen these index out of bounds exception. You're trying to access a value from an array list that doesn't exist. You have an array list of size 5 and you ask it for the element at index 10. It's going to throw an index out of bounds exception. If you don't catch that exception, your program crashes. So usually your program just crashes. If a null pointer exception, when we started talking about linked lists, you start seeing a lot of these when you work on your task 3, when you're working on that. You would see null pointer exceptions if you didn't have your proper null checks and you tried to access an object when the reference was actually null. You're going to get that null pointer exception thrown by whatever method you called. And if you don't catch that, program crashes. And then I have a typo on this slide. Stack Overflow is actually an error. You can't catch a Stack Overflow error. So a little bit of a typo here. But Stack Overflow is something that's thrown that you can't catch, your program just crashes. You ran out of stack space. There's nothing you can do to recover from that. So if you don't want your program to crash when you try to read a file that doesn't exist, we're going to have to catch that exception, which looks like this. So here in comes the try catch block. So if this is going to throw an exception, we don't want our program to crash. We just want it to handle, we want it to handle that gracefully. If we get a file name that doesn't actually exist, we want to have some specific behavior of where we handle that. Is there a seg fault in Java? I've heard rumors that it exists, that you can get a seg fault in Java, but it's extremely difficult to do. I've never been able to do it. I've never tried actively, but I've heard that you can actually get a seg fault in Java. But Java has so much checking, especially with this exception system, that usually you get an exception thrown, you don't actually get a seg fault. You'd really have to try to get a seg fault. In 220, for those of you who don't know, in 220, when you work in C, you're going to see a lot of seg faults. Pretty much, like, at least whenever I code in C, about half my errors, my runtime errors, are seg faults. And you just get seg fault and your program crashes and you get almost no information. It's really frustrating. What a seg fault means is that you tried to access memory that you're not allowed to access. So when we start our program, we get our stack space, and then we can ask for heap space. We have certain memory addresses that we're allowed to access. And if we go outside those bounds, the operating system says, and you get a seg fault, segmentation fault, and program crashes. You try to do something you're not allowed to do, it's going to shut you right the hell down and stop your process completely. We don't, which understandably, we want that to be the case because we don't want other processes messing with our section of memory, memory that's allocated to us. We don't want another process going in and like changing values on our stack. Aside from just introducing all kinds of wild bugs that could open up, it also opens up the possibility for all kinds of security issues if you can get some process running on somebody's device and that process can just go all over memory and mess with everything. Huge, huge security implications. So seg faults are very important to protect us, but you will see them when you start coding in C, unless you're an absolute god programmer. All right, so we're using the try catch block. What this means, this is one thing that's pretty well self-documenting. We're going to try to run this code. We're going to try to run this code block. And if, while we're running this code block, there's an exception that's thrown, we're going to catch that exception, which means we're going to catch an IO exception in this case, and then run this block of code. So we're going to try to run this code. Try to run anything in the code block. And we're expecting this to potentially throw an exception in some cases. In this situation, Java makes us have a try catch block or throws. I swear, if I see anybody with throws right here, and I will see some of you with throws right here, don't do that. That will shut Java up. Java will say, oh yeah, you added throws to your method. But it's not what we're doing here. It's just not what we're doing here. I won't show you that in lecture aside from this very quick aside. Whenever I see that, it means you told IntelliJ to just fix it for you. You had the IDE write code for you that you don't understand. Don't do it. Just don't do that, please. And then I have to give you a mini lecture in office hours like, well, you had the IDE write code for you that you don't understand. What the hell are you doing? Just pay attention to lecture and do it the way we learned. So don't be that person. So we're going to try to run this code. This will also shut Java up by using the try catch block, but it's the second autocorrect in IntelliJ, so anybody just blindly clicking things won't find this one. So we're going to try to run this code, and if it throws that IO exception, because this can throw an IO exception, we're going to catch that exception. So if an exception is thrown, this code block stops completely. It doesn't run the next line of code. It just stops. Wherever it is, all the stack frames are removed from the stack that were added to the stack in this block, and we go to the catch block. So we're going to go to a catch block. I noticed this looking over my slides this morning, but I didn't fix it. Sorry. But this is a little off center. Uh, but we're going to catch it, and specifically this will throw an IO exception, which is the exception that's thrown if the file doesn't exist. An IO exception, or input-output exception. This is the type of exception that's going to be thrown. So when we write our catch block, we're going to specify, kind of like this is a parameter list, we're going to specify the type of the exception that we're catching, and then give it a variable name. This E is just the variable name I chose. EXC, or if some people want to spell it all the way out, exception, whatever you name it, it's going to mean this is the exception that's being thrown. I'm not even using the variable, so I just named it E because I'm just not using it. So I don't need to have a good descriptive name, I don't feel. So if this exception is thrown, then we're going to run this code block. And for what it's worth, we won't do it in this class, but you can have multiple catch blocks. If you expect multiple different types of exceptions that could possibly be thrown from your try block, you can have multiple catches. You can say catch IO exception, then the block, and then after this block, catch some other exception type, and then another block. You can even have finally, which is always runs whether, no matter what exception was thrown. We're not going to do any of that in this class. We're just going to catch IO exceptions. But that is possible if it's something you want to do. Something you will do at some point in your career. You're going to have multiple catch blocks. So I want to mention it. So if an IO exception is thrown, so if this file name doesn't exist, if it's not an actual file, we're going to run this code. And in this case, I'm just going to return an empty array list. This mirrors what you're asked to do in your homework for both of the methods that you have to write for task 6. If the file doesn't exist, it will either return an empty array list or an empty hash map, depending on which one you're... Actually, no, they both return array lists, don't they? Depending on which one you're working on. All right, so that's reading files. And then once we read the file, these are going to be CSV files in this course. So how do we handle those CSV files? Let's talk about it. So what we're going to do is just split on commas. This is the simplest thing to do with a CSV file. And I have another disclaimer. I feel like I have a bunch of these, but I have another disclaimer. This is not the right way to parse CSV files. Don't go around telling everyone, oh, Jesse said this is the right way to parse CSV files. Just split on commas. It's not. It's not. It's more complicated than that. We're simplifying it just for 116. All the data has been curated to make sure that this will work on the data that I give you for the assignments. But it's not the right way to parse CSV. For example, what if the data itself contains a comma? You're going to chop a value in half and not get what you're expecting if the values contain commas. So if the value contains commas, the CSV format will escape that by surrounding that value in double quotes. And then the question becomes, well, what if your values have commas and double quotes? Now you have to escape the double quotes. I believe that happens with a slash. I'm not 100% sure. Probably a slash. I feel like that's usually the way to escape things. But it could be something else. Maybe it's a double quote. I don't remember. But then what if your data contains slash double quote in it? So it's just a cascading thing. What happens when your escape characters are contained in the content? So it gets more complicated. We would just pull in a library for this, but that was also fairly complicated in Java. So the easiest thing, just split on commas so we can talk about the stuff we want to talk about and not get caught up on all of the details. So to split a line on commas, pretty simple, at least because you've already done this in 115. And if you came from somewhere else, not 115 at UB, you've probably done the same thing. You've done at least something similar in your CS1 course. Is we're going to split on commas by just calling the split method. So the string class has a non-static method named split, which will take a string as a delimiter, and then it'll split the string on that delimiter and return an array containing all of the values that are split. So for example, if this string, if line is A, comma, B, comma, C, and I call split on comma, that's going to return an array with the values A, B, and C as 3 different values in that array. Now I said array, but we haven't worked with arrays at all this semester. So just like list in the previous example when we're reading the lines of a file, if you don't want to work with a list and you don't want to work with an array, just slam it in your array list constructor. This, since it is an array, not a list, we do have to convert it to a list. So we're going to use our familiar arrays.asList, convert the array into a list, and then convert that list into an array list. Now we can just work with array lists. We only have to learn how to use one sequential indexed random access memory data structure. Array lists, we only have to learn array lists. We don't have to worry about any differences in syntax between these different data structures. If you want to use plain arrays, by all means, go for it. Just when you write a method, if the method in the homework says return an array list, make sure you're converting whatever your data is into an array list before you eventually return. But your splits, usually I'm not asking you to return the splits directly. So if you want to work with this as a plain array, by all means, go for it. If you don't want to worry about that, and I'm not going to show plain arrays this semester, just slam your stuff into the array list constructor and use your array list. And finally, you will have situations where you want to convert strings to numbers. For example, the rating of a song is going to be a string when you read it. Your splitting of strings is going to return an array of strings, but the rating needs to be handled as an int. So we want to make sure we get that conversion. How do we do that? Well, integer.parseInt, double.parseDouble. This is going to convert our strings into numbers as long as they are well formed. So if we have a well-formed string, or a string that represents a well-formed integer or a well-formed double, we can call this parseInt or parseDouble. If it's not well-formed, we're going to get an exception thrown. So if I have the string FOUR, to me and you, that says 4. To the parseInt method, that's a string that is not a well-formed int, and it will throw an exception and say this is not... I think it's malformed number exception, if I'm not mistaken, that it'll throw. And if you're not catching that, program's going to crash and fall apart, burst into flames. So we want to make sure we're careful when we call parseInt and parseDouble, that we're calling it on something that will be a well-formed int or a well-formed double. Okay. And that's all the concepts for today. And we got, 45 minutes. Actually, I'll get some good live coding in today. So we want to spend the rest of the time doing live coding. I want to, one, just show you examples of everything we just talked about, reading CSV files, parsing. I'm going to parse some cities data in our code. And two, which will kind of be a new concept, I suppose, is testing methods that take file names as parameters. How do we write tests for such code? And the short answer to that is you're going to create your test files and then have your own testing files, which are going to be ran against the correct and incorrect solutions in Autolab. So you'll be creating your own test cases with your own test files. All right, I'll take a quick breather here if anybody has some quick questions here. We can get those questions out there. No, wait, at least the 20-second delay to get something out there, because we're going to shift gears pretty strongly here. Typos in my description. And write this method. Where are the exception, and how do I know which one I should catch? For this course, the only exception we're going to care about is an IO exception, specifically when we're reading a file that doesn't exist. We're not going to go through, you're not going to have to catch any other exception. Oh, yeah, when I mentioned if you don't catch the exception for the parseInt and parseDouble, don't actually do that. Just only call those methods when, you know the input is going to be well-formed. Don't worry about catching those. I just mentioned that, like, outside of 116, you might be in a situation where you want to catch that. In 116, CSE116, you don't have to catch your malformed number exceptions. There's no reason to do that. Let's do this. So we want to write a method named load countries. Whenever I have a method name or something specifically named in the homework doc, or the requirements, wherever I'm getting, hey, this is what you need to write, wherever I'm getting it from and what I recommend you all do from the homework doc, cut and paste it, copy it. This load countries is the file name. If I type this myself and I make any little typo, maybe I have a lowercase c here, that's going to be enough to guarantee that Autolab's going to reject my solution. I'm going to say everything works great on my end. I submit to Autolab, and Autolab doesn't even run it. It just gives me error. I cut and paste, just one less thing that I have to worry about when I submit. Personally, something I like to do. Public. So it doesn't say the access modifier. It doesn't say static or anything. So I know this is just a public method. It's going to return a hash map. A hash map of country, and if this were an actual homework, I'd be more explicit about everything. I was a little hand wavy at the end here because I'm going to explain it all in lecture. But mapping each country code to an array list of cities. What's a city? What's a country code? What are the actual types? Well, the country code is going to be a string, and the cities, I'm going to create a new, what am I doing? I'm going to create a new type of city, and that's what we're going to use for that return type. So I'll create that class in a second, but let's get the rest of this written. So here's my pasting the name of the method to make sure I don't get it wrong. And then it takes a string, which is going to be the name of the file. And when I write a method like this, and I have the method created, but I'm not ready to really write the method yet, I'll what we call stub it out. This is going to return a hash map of, whatever. I don't want to create a new hash map. I just don't want to think about it at all. I'm just going to return null just so this compiles, even though I'm not ready to write the method at all. I just want it to compile so the IDE shuts up for a bit while I handle some other business. That other business is creating a city class. Now, we're going to read data in this format, country code, where each line of this file represents one city with the country code for that city, the name of the city, the region, actually region code for that city, the population of that city, latitude and longitude to get the location of that city. And the data we're going to read is this data right here. It has a header line with all of the fields that I just mentioned, and then a lot of cities with the data that we expect. The country code, name of the city, the region code, population, latitude, longitude. If we look through this, we can find Buffalo, New York. This file has almost 48,000 cities in it. So we have a lot of data. And we can look up, whatever city we want. Buffalo, the population of a little over 250,000. Population's a little light because it doesn't count the suburbs of Buffalo. And then our lat long for the city. So tons and tons of cities in here. And we want to write code. This is why we would write code to read files. We don't want to store this in some other way or hard code it into our methods, our programs. We don't want to do that. So we're going to store this on our hard drive and then read this data in our code. So what we want, and what I usually do, by the way, let me get Buffalo, New York, actually. What I like to do when I'm working with data like this, I'll take a sample line from the code and paste it, or from the data and paste it into my code as a comment, just to remind myself of what the format is for a city. I'm going to do that with the city class too. So let's create a new class, new Java class, city. Add it, but I'm not gonna commit this code. So this code, like the finished example, it'll be slightly different than the way I do it today. But the completed example for this and more than I'll get to today is in the repo. So if you want to see what the final product looks like, feel free to check that out. So city, and I want some instance variables here. Let me get just my reminder here. So I want private string country code, private string. One thing I've always wanted to learn is how to type without looking at the damn keyboard. Name. It's one skill I've just never practiced. So I always got to look down. Private string region, which is New York in our case, NY. Private int population. Private double latitude. Private double longitude. So I'm going to create all of my instance variables here. Now I want to show a few things. I usually regret showing this each semester, but I'm still going to do it because, I don't know. I like, I don't know. I'm just going to. And I'll explain what I mean there. So what I want is a constructor that's going to take these 6 instance variable values as parameters, and I want getters and setters for all these. And I'm going to sit here and I'm going to type public city and all my variables and everything. I don't feel like doing that. So I'm going to right click and I'm going to say, hey IntelliJ, I'm about to write some code that every Java developer since the beginning of Java has written. It's a standard format. It's a getters and setters and a constructor that takes all the instance variables. Can you just maybe do that for me? I'm going to go to generate constructor. I'm going to select all of my instance variables and bam, there's my constructor. I'm going to go, hey IntelliJ, I need those getters and setters. Generate getters and setters. Select all of my instance variables. There's all my getters and setters with the names that we expect. Get region, set region, returns void, take return string, all the things that I expect. The only thing it misses is I like my explicit this dots in my getters in all my methods, but whatever, we can't get everything. So I have all that code that I just let IntelliJ do for me. Don't have to think about it. I have a related problem. Do I use this class somewhere else? Array list of city. I didn't import array list, but it's not mad about my lack of an import for hash map. Oops. How do I do that on this? That's not going to be it. Alt enter. Okay. Alt enter. To get my imports in there. So the reason that I don't like showing that stuff is students take that too far and they'll have IntelliJ generate other code for them. Like as I mentioned earlier, if somebody has throws IO exception in their method signature, I know that they're just being a little heavy-handed with the auto help from IntelliJ. So it's a tool just like any other tool. You need to know how to use it. If you know how to use it, it can save you a ton of time. If you don't know how to use it, it can waste tons of time. Somebody who does that autocomplete throws an IO exception instead of studying lecture and doing it the way I showed, they spend many extra hours that they didn't need to spend because they're like, why does Autolab keep rejecting my solution? Well, it's because you did something bonkers that it didn't expect. All right, so we want to read this file name. If only VS Code has that. VS Code probably does have an extent. VS Code has extensions for everything, but it doesn't come with that out of the box. Or just use IntelliJ. I mean, so we want to read this file and create new cities. And when I code, by the way, I usually code out of order of what I actually, of the order of the code. Like my code, I'm not going to write the first line, then the second line, then the third line. I usually write code just my style. I'll write it in the order in which things pop into my brain. So I know at some point I'm going to need a hash map. Well, this is actually going to be the first line. But I'm going to need my hash map of string to array list of city. So this hash map is going to be for each country by country code. So like this hash map will have one key of US. Each country code is going to map to an array list of cities, which will be a city object for every single city with this country code. So that's what we want to build. I'm going to initialize this to a new hash map. And I'm eventually going to return that hash map, which I did not name. I'll name it countries. And I'm eventually going to return that. So my whole goal of this method is to populate that hash map. At some point, I'm going to want to create a new city. I might as well name it city, because why not? City equals new city of country. I don't feel like typing code, so I'll just type country, name, region, population, latitude, longitude. So eventually I'm going to want all of these values. String country, string name, string region, int population, double lat, double longitude. So eventually we want all that, and then we want to add this city to our hash map. So how am I going to get all of these values for a city? Well, we want to get our file IO stuff in here. So let's get our file IO. This, I just memorized it at this point. So if I want to read a file, it's files.readAllLines. Read all lines, paths. And IntelliJ is being good about auto importing. As I use the files object, as I use the paths object, it's going to import them for me. Paths.get and the file name from the constructor. So it's going to tell me read all lines, throws an exception, unhandled exception. This will throw a Java IO exception if the path that you give it isn't a real path. So we're going to have to catch that exception. Now this is where the autocomplete crow gets in. Oh, it is. Oh, yeah. So add exception to method signature. This is not what you want, but anybody just clicking the first IntelliJ fix my code for me, that's what they're going to click. The try catch is what you want. I'm not even going to use the fix it for me here because we don't do that. So I'm going to do, we do that sometimes when it's helpful. I don't think it's helpful in this case because it's easy to get the wrong thing. Catch IO exception. I have to type it all out because it's not imported yet. I'm gonna have to import it. I'm doing Alt-Enter to import. That can be a little dangerous too because you might not get the right thing imported. You might get something called IO exception from a different package. Sometimes I like to double check Java IO exception. That's the one I want, so I'm good on that. But sometimes you'll get the wrong thing imported. So you have to be careful about what you're importing as well. But in most cases, the auto import it can get the right thing. Another thing you got to be careful with, remember, it's a tool. The shortcuts can help you. They can save you time, but you need to know how to use the tool. You can't just, there's no magic button, IntelliJ write code for me. Yes, there are things that do that. Unfortunately, a lot of that these days. But if it writes the wrong code, you still have to know how to use that tool, fix that code, and get it to do what you want it to do. So when we catch this IO exception, in this case, if this file doesn't exist, I just want to return an empty hash map. So if we catch this exception, I don't even want to do anything. I'm going to let it just return this empty hash map. So I'm fine with this the way it is. And then I want to store this in an array list of string. Alternatively, we could go right into new array list. Let me finish my thought here. New array list. Convert this to an array list from a list. Alternatively, we could do this. I think it's a little more confusing when I'm showing a topic for the very first time. Oops. So I don't want to do it this way in the final product, but I will show you at least. String line, use our for each loop and just iterate over that list directly. This is perfectly fine to do if you want to do it this way, except I missed a closing paren. And then we don't have to worry that this is a list. Whatever, it's something that can be iterated over. Let's just iterate over it using our loop and not think about array list or anything. I'm going to use the array list. Oh, I know what I'm doing. I know what I'm doing wrong there. I switched my Alt and Control keys so it feels more like a Mac, but then I'm hitting the wrong button in certain situations. I think, or is that my, no, that's my mistake. I know my mistake. I only switched the, that's why I'm all messed up. I only switched my left Alt and Control, my right Alt and Control are the right way, and my left Alt and Control are backwards. Just to make sure I'm thoroughly confused whenever I do anything. I don't know why I set it up like that. String, for string line in lines, and I want to loop, and all this stuff I want to do at each iteration of the loop, so I'm going to end my loop after all of that. And I'm going to have some lines after it as well. And then for each line, I want my array list of string, and I always call this variable splits. Line dot split on comma. I didn't do my extra stuff. Arrays dot as list. Get my parentheses where they need to be. Okay, and then we're ready to actually populate these values. So this is going to be splits dot get 0, and here's where I'm going to refer to my sample line again. The country code is the first value, so that's going to be at index 0 after splitting on commas. The name, and let me copy and paste this because I'm going to be doing the same thing over and over here. The name is at index 1. The region is at index 2. The population is at index 3. The latitude is at index 4, and the longitude is at index 5. Then we need our integer dot parse. Oh my goodness, I'm all over the place here. Integer dot parse. Double dot parse. Because these values are ints and doubles as opposed to strings for the first 3, so we want to make sure we get that. I swear I added my closing paren there. So we want to make sure we convert these. The population is an int. We want to make sure that's represented as an int. Doesn't make sense to have point some amount of people. There's always going to be an integer value. Latitude and long, very much doubles. There will be decimal portions to both of these, so we're parsing those as doubles and get them in our constructor. All our errors went away in this constructor, so we're feeling good about that one. Next is kind of an interesting topic that comes up just naturally in this course a few times. This is the first time, but something called lazy initialization. So we have a situation where we have this hash map mapping countries to all the cities in that country. And when we have a city, we know what country this city belongs to, but we don't know if that country has an entry in this hash map yet or not. So we want to do two different things, whether or not this country is in the hash map already as a key, or it's not in the hash map as a key. So what we're going to do is lazy initialization. We're not going to pre-initialize all of the countries, which we could do. We could go through this file one time and for each country, get that key in the country's map with an empty array list, then go through the whole file again and populate all the cities. I mean, that's fine, but that would be like a pre-initialization. A lazy initialization initializes something at the very last moment. As soon as we actually need that value, that's when we initialize it. So initializing at the very last moment can improve efficiency, not something we talk about in 116 much, but just incidentally this topic comes up, is we want to check. So what I want to do is if countries contains key country. So if I've seen this country before And actually, I want to do the opposite of this. If I have not seen this country before, then I want to initialize it. I know this is the very first time I've seen this country. So then I'm going to say countries.put country new and initialize this array list. So that's lazy initialization. At the very moment I have to add this country, add a city for this country into the hash map, when I need to do that for the first time, that's when I'm going to initialize that array list. And then, regardless of whether we just initialize this or not, whether it's an empty array list or an array list with a bunch of values in it, I'm going to say countries.get country. So I'm going to get the array list for this country. Remember, this resolves to a reference. So I have a reference to that array list, and I can add to it. So whether or not we just initialize this, so countries.getCountry, if we just initialized it, this will be an empty array list. It'll resolve to a reference to the empty array list that we just created. Or if it's not the first time we've seen this country, then this code didn't run. We have an array list with other cities in it, and this resolves to a reference to an array list with other cities. We have a reference to an array list object. We can call all its methods. We're going to add another city to that array list. And I'll maintain that this code is almost done. So we're going through all the lines of the file, reading the city represented by that line, checking if we need to lazily initialize that country in our hash map, and regardless, adding to our hash map, adding the city to the hash map under that country. So this gives us an array list of countries to, or a hash map of country codes to all the cities in that country. There is an intentional bug in this that we'll talk about in a second. Not quite a second, but we need to talk about testing. I don't have a ton of time, and we will get to the juicy bits in that time. So my question here is, how do we test this thing? I got no code in the test. I just have this this empty shell of a class right now. So we want to know how to test this thing. Yeah, I mean, you can use it to read manga, but I'd probably just read the manga. It might be easier with your eyeballs. Maybe if you put it like into an auto translator, that would be helpful. I don't know. But we have this file. So what I want to do is write a test case that's going to give this method a file to read. It's going to read that file, and then I want to check to make sure what's returned is a hash map containing all of the information in that file. And that's a tall order. I got 47,977 actually cities in this file. I'm not writing that test case. I don't care what you say or what you do. I'm not writing that test case. It would take me way too long. I would end up writing some automation to automate the generation of my test case, and it kind of goes in a weird circle because that automation is basically going to be the method that I'm testing, and what am I testing? Like, it's not going to end up good for us. So what I want to do is take some very small subset of this code or of this data and then use that as a test. So I have a few test files here. One with just Buffalo, New York. I just picked whatever I want from that file, and another one with 4 cities where one of the at least 2 of the cities are from the same country to make sure I'm handling those situations, but very small subsets of the data that we're given. And if I were to fully test this, I would definitely create more test files with different situations. Have at least one test file where 2 different countries have more than 1 city in them. But just for the lecture example, these 2 tests I think we'll be fine with. So I'm taking a very small subset, creating that test file, and when you create your test files, it's good practice in general, but in 116 it's required by Autolab. Put all of your data files in a directory named data that's in the root of your project. So this is not in your source folder. This is in the root of your project. Create a file named data, and then put your test files there. Autolab is looking specifically in this directory, exactly in this directory for your test files. So I've seen students name this with a capital D, for example. That's not going to work. Autolab's not looking for data with a capital D. I know it's very picky, very particular, but this is the way to get it set up so I can run your tests when you have test data in test files. So cities test1, I want to go to my test code, and my file name is actually going to be the full name of that file, starting at the root directory of the project. So your file name in your test should start with data / cities, no autocomplete on this one, so I gotta type out the whole thing, .csv. So I have to type out the full file name, including directory, starting at the root of the project. So we start at the root, go to data, and then cities test1 is going to be this file right here. I'm going to cut and paste the contents here so I can help myself write the test. I'm going to call the method that I'm testing. So countries example dot, I did not make that I actually did want that to be a static method. Write a static method, public static. That way I don't have to create a countries example object to call this method. Dot load countries file name. That's going to give me a hash map of string to array list of city actual, and I'm going to create another hash map, which is what I expect. What I expect is a hash map with one key, oh my, which is going to be US, and then a new array list with a arrays.asList new city, and here is a very strong cut and paste scenario. I don't want to mistype anything in all this, especially when one capitalization will mess me up. There we go. So that's what I expect. And now I want to compare these two hash maps, which is easier said than done here. So I want to compare two hash maps that have strings to array lists. This can get a little tricky. And cities, this is a different city object than the one that is going to be in actual. So I can't compare these cities using equals either, because that's going to compare them by reference, and they refer to different objects. So I have to write some custom comparisons with my cities. You know, I got to do a lot of work here to compare these things. So let's do a lot of work. And when I'm doing something like this, especially when I know I'm writing another test case, what I want to do is write a helper method. So just like we had compare doubles, I'm going to say compare country maps. It's not the best name because it sounds like I'm checking cartography, but whatever. I'm leaving it like that. Actual. So I want to write a method that's going to compare these two things. Here I am going to use some autocomplete. I'm going to have it create the method for me. I like to put my helper methods at the top. That just gives me the method signature. It said, hey, you're using this method but it doesn't exist. You want me to make it exist? And I said, yep, I do. So we want to make sure that these two hash maps have all the same values. Hash maps have no sense of ordering. I can't just iterate over these hash maps and check them all. So we got to be a little creative about what we do here. Why does the file name need to contain data? Because file names in your programs are always run from the root directory. So your file name has to be relative to that directory. I have data, my files in the data directory. So I have to have data / to specify the directory and then the file name. So I have two hash maps. Whenever I'm comparing two data structures, and it's reasonably possible, the very first thing I want to do is make sure they're the same size. For linked lists, this gets a little bit different because we're checking if we reach null at the same time when we're going through the list. For this one, I can just straight up check their size. So my first assert, I'm going to assert equals expected.size, actual size. I did use assert equals in lecture, I'm like 90% sure. But assert equals takes two parameters, or two arguments, and asserts that they're equal. Instead of using assert true and doing our equality checks directly. I think I mentioned it very briefly in the last testing lecture. But assert equals can be handy. Assert true is like your sledgehammer. It's going to get you out of any situation. Anything you need to test, it's going to do it. You can always write a Boolean expression. But there are other assert methods that can just make our lives a little easier. Assert equals, and then, so if they're the same size, I'm going to iterate over the keys of my expected map. So for string country in expected, I always iterate over my expected data because I don't trust my actual. You should never trust your actual data because you don't know where it came from, how it was created. That's what you're testing. So if you're just trusting that it has what you expect it to have, you're not really testing anything. So I want to make sure I'm iterating over my expected. And then for each key in the expected key set, so each country in my expected, I'm going to assert, and here I have to use my sledgehammer, assert true. I want to make sure that that key exists in my actual. So what was actually returned? Does it contain this key? Because it better contain that key. If it does, then I know that we need to check that array list. So let's get some array lists of cities, the capital C. Expected cities equals expected dot get the key country. So I want to get the expected cities. I want to get the actual cities. And I don't think I got a chance to show this in lecture yet. You did need it for your task 4. So I want to get an example out here, even though a lot of you have already had to do this. I think a lot of you just did it manually and checked the indices. But what I have is a situation where I want to compare two array lists. So I want to iterate over these array lists. Oh, first assert equals, first the thing we already did. Expected cities dot size. I'm comparing two data structures, so I want to make sure their sizes are equal. Actual cities dot size. And then I want to iterate over the indices of my expected cities. Now they're the same size, so in this case, the size is going to be the same regardless. They're the same size, so I could use actual here, but just force of habit, I'm always going to iterate over my expected because that's the ground truth. I know that one's right because I hard-coded it right here. I know that's the right size. So for the indices, I'm going to get the cities, city expected city equals expected dot get the value at index I. So get the first city, then the second city, then the third city, expected cities. And then my actual city, actual cities. Now I need to compare two cities. For this, I like to do another helper method. It's really unrelated to the rest of the stuff I'm doing. I could easily put this in the same method, but this method's getting a little bloated for my taste as it is. So I'm going to defer to another helper method. that's going to compare two cities, which is a helper method. Like if I'm writing a program that handles with this data all over the place, probably gonna have more than one situation where I want to compare two cities. So I'm going to create this helper method. And this one is pretty straightforward. Assert equals expected city dot get country code actual city dot get country code get name get region. Oh, it's the top one. Get region get population get lat get long. And with these last two, these are doubles, so we always have to be concerned about our truncation errors. We want to make sure we do that epsilon comparison, take the absolute value of the difference, make sure it's less than some small value. Now that we're using assert equals will make this a bit easier for us. Now that we know the concept, I want to make sure you understand the concept and do it with assert true first. But now that you understand the concept, we're past that part of the course. You can use assert equals, and when you give it two doubles, you can give it a third parameter, which is your tolerance, which is effectively the epsilon that we were using. You can give it a third parameter, and it'll say, as long as these two are within 0.001 to each other, we're going to be good, and we're going to call them fine, and the assert will pass. Okay, so that's an example of going through two hash maps and making sure they all have the same values, and going through two array lists and making sure they all have all the same values, which this is when you're going through your movie, the cast list. You want to make sure you iterate through both array lists and see if they're the same thing while ignoring case. That's an example how you do that. Those of you who did it, I'm pretty sure you just hard-coded the indices and said, I expect index 0 to be this, I expect index 1 to be this, I expect index 2 to be this. But if you want to write it in a generic way, here's a way to write it generically that'll make it easier to write more test cases. If I want to add, we won't have time here, but if I want to add this second file and add another test case, I hard code my expected hash map and then call my compare countries maps again, and all this code just does work for me after that. So it's easy. My goal with testing is always, I shouldn't say always, but almost always, to make it very easy on myself to add more test cases. Especially when you want to add a lot of testing, you don't want to make it very painful to add another test case. I want to create another test file. I want to get all that data into a new hash map of my expected for that test case, and then everything else should be reusable in helper methods. So it's as easy as possible to add new test cases. And with a few minutes, let's run this test and let's see it. It's not even going to fail. It should crash and burn. And we'll get a little bit of debugger in here. So I don't have time, compiler, but we're going to get a malformed number exception. Number format exception. I thought it was malformed, but number format exception on the string population. And if I go to the line, the top blue link is going to take you to the line that threw the exception. So this line here threw a number format exception. It was uncaught, so it crashed the program, which is fine in our cases. We're not going to catch a number format exception here. But what I'm going to do is set a breakpoint right here on the line that causes the issue. The debugger is going to stop before the line on the breakpoint. So let's run this again in the debugger and take a look at what's happening. So I'm running this on this file, on this test1 file. My line is this line, which is the first line of the file. So my splits index 3 is the literal string population, and I'm trying to parse the string population as an int, which isn't going to work. So when there's a header line on our file, we want to make sure we handle that some way. There's a lot of different ways to handle this. I'm just going to choose one. If let's do a quick and dirty one. Country, comma, if line dot starts with this, continue. Do I even want to show that? But let's do it this way. If line does not start with country, then run all of our code here. So we're effectively skipping that header line, and now our test should hopefully pass. But we need to skip that header line some way, one way or another. I'm going to say if the line starts with country, comma. Now country codes are 2 characters. So country is more than 2 characters, so I don't have to worry about this skipping an actual line of data. So if I have the header line, let's skip it. It's a quick and dirty way. Usually when you read the lines, you want to get the first, what I could do is get the first value out of this data structure. That would be a better way to do it. But to get in under time, that's what we had to do. All right, I have to go. We're going out of town for the weekend, so I don't have my office hours. Gerline, it looks like she pushed hers back by an hour, so there are still office hours today. So I will see you all on